Hi guys, today we are going to start a new unit, Unit 11, and Unit 11 is all about sequences and series. This unit's going to be a little different than what we've been doing up till now, and so maybe for some of you that's a good thing. You're thinking, oh, I get to kind of hit a reset button and try something different. Maybe some of you it'll take a little more effort, but either way, this is a pretty short unit, and I'm excited about it. I like this unit. I think it's kind of fun. It helps us to look at the world in unique and different ways because we start to see patterns around us and things that are happening around us. So let's dive right in. So when we're talking about mathematical patterns, there are a few questions we want to answer. The first one is, what is the pattern? Well, it looks like I started with an equilateral triangle, and each time, or each change, I guess, was that I like cut it into thirds here, or cut each side into thirds, and made a new equilateral triangle. Cut each side into thirds, so I took this side, this side, this side, this side, etc. This is my pattern. I'm taking each side and cutting it in thirds to make more equilateral triangles. Another question we might ask is, what will the next shape look like? If I continued this pattern here, what would happen after it? And then another way to look at it is, what is the rule? And for a problem like this, it doesn't make as much sense, but we're going to look today at how to write mathematical patterns and rules. All right, so first one, describe the pattern formed, and then find the next three terms. So when we're looking for a pattern, we're seeing, how do I get from one term to the next? So to get from 27 to 34, my best option is to add 7. And we always want to make sure that this works for all of them. Double check, is 34 plus 7 41? Yep. Is 41 plus 7 48? Yep. So my rule, or my pattern, excuse me, is add 7 every time. So then it says find the next three terms. So I'm going to add 7 3 more times. 1, 2, 3. So if I add 7 to that, I get 55. If I add 7 to that, I get 62. And if I add 7 again, I get 69. So there are my next three terms. Another one could be, describe the pattern formed, find the next three terms. And now I'm looking at, how do I get from 243 to 81, 81 to 27, and 27 to 9? And the pattern here is going to be that I'm dividing by 3. Again, we want to make sure that it works for all of them. I actually kind of had to look down here first, because 243 to 81, I was like, am I subtracting 162? What am I doing? That didn't work for all of those, though, so I had to look at dividing. So 27 to 9, I divide by 3. So my pattern would be that I divide by 3 each time. And so then my next three terms, when I do 9 divided by 3, I get 3. 3 divided by 3, I get 1. 1 divided by 3, I get 1/3. And that's it. So there are two types of formulas that we're going to look at. The first is a recursive formula, and it defines the terms in a sequence by relating each term to the ones before it. And we're going to use this right here, this a sub n minus 1, to denote the previous term. A sub n means like the current term, or the term that we're trying to find. So for example, a sub 6 would be the 6th term, or the value of the 6th term. So then a sub n minus 1, in this case, right here for this example, would be the 5th term. I just say what's the one before the 6th term. So on these two problems before us, we would say, okay, we're adding 7 every time, so my formula would be a sub n equals a sub n minus 1 plus 7, because I take the previous term and add 7 to it. Here, it would be a sub n equals a sub n minus 1 divided by 3. That would be my rule every time. An explicit formula expresses the nth term in terms of n without referring to any of the previous terms. So this is where we think about things like the first term, the second term, the third term, the fourth term, and we say, what is the value of the fourth term? And the formula is not going to rely on this previous term. It's going to just use the value of the term number and get the result. And so we're going to look at an example of each of these. So first we have describe the pattern formed. So let's start with that. Let's see what's happening every time. So 17 to 11, I subtract 6. Looks like that's going to work all the way through, subtract 6. So my pattern is subtract 6 every time. And then it says to write a recursive formula. So this is relying on the previous one, the previous term. A sub n equals, I take the previous term and subtract 6. Okay, so I describe the pattern, write the recursive formula, and now I need to find the next two terms. So I've got the first, second, third, fourth, and fifth terms. So to find the sixth term, I'm going to say, okay, I need the fifth term minus 6. The value of the fifth term is negative 7. And minus 6 would give us negative 13. It might seem silly to show all this work, but this is really what a recursive formula is about. So I do want you to at least show this much. Don't just put negative 13, put a sub 6 equals negative 13. We want to start thinking of it in this notation. So then we also need the seventh term. A sub 7 equals the previous term, which is a sub 6 minus 6. A sub 6 was negative 13 minus 6. A sub 7 equals negative 19. And there you have it, recursive formula. So we did that for the next two terms. All done. All right, last one. Describe the pattern formed. So let's look first at what's happening every time. Can you see it? We are adding 3 every time. So add 3 each time. Then it says to write an explicit formula. So we're not using the previous term. We have to use the term number. And this can get a little tricky. I like it because it's kind of like a puzzle to me. The best way that I found is to think about it this way. Whatever number or whatever value we're adding every time, in this case 3, this is going to go first times the term number. So like 1 times 3 and 2 times 3. And I know you're saying, hey, wait a second. How do you teach math? 1 times 3 is 3, not 4, and 2 times 3 is 6, not 7. So then we have to think about what do we need to add or subtract to finish this formula and to make it be true. So if I do 1 times 3, I get 3. So really what I'm saying is, what do I add or subtract to 3 to get 4? I add 1. What about the second term? If I do this one here, I'd be saying 3 times 2 is 6. What do I add or subtract to 6 to get 7? I add 1. And so what's going to happen is my formula is going to be 3n plus 1 equals a sub n. And I do want you to put this equals a sub n or a sub n equals because it's helping us to see that it can help us find any term. I like explicit much better than recursive because recursive is limited to knowing what the previous term is. Once I have a recursive formula, I can find the 6th term, the 7th term, I can find the 118th term. It doesn't matter. I can find it because I have the rule. Rather than sitting there and plugging in plus 3 118 times, I can just put in 118 for n and solve it. So I have my pattern, my explicit formula, and I need to find the next two terms. So for a sub 6, and I'm going to use this, I'm not just going to say, oh, plus 3, but I would get 3 times, not 3, 3 times 6 plus 1. So a sub 6 would equal 18 plus 1, which is 19. And that makes sense. If I go like this and go plus 3, I get 19. Good way to check my work. A sub 7 equals 3 times 7 plus 1. And a sub 7 is 21 plus 1, which would give us 22. So these would be my next two terms. When you're practicing today, please don't just do +3 and +3. Actually practice substituting in values, because we are not really going to use a whole lot of these recursive formulas. We're mostly going to be using these explicit formulas. And so I want you to start practicing with them now so that you can start to familiarize yourself with them and to get more comfortable with them. I will post an assignment in Google Classroom, and let me know if you have any questions. Thanks, guys.